In this lesson, we want to look at approximations, and under approximations, we are going to look at absolute errors, relative errors, and also percentage errors. So, under absolute errors, if a dimension d is given to the nearest n, then the error is given by n over 2. Okay, so I have to state one thing here. If you are not given to what the measurement is measured to the nearest, then there's a way in which we solve. Okay, so in this lesson, we want to look at approximations, and under approximations, we are going to look at three things: absolute errors, relative errors, and percentage errors. So we'll start with absolute errors. If a dimension d is given to the nearest n, then the error or the absolute error is given as n over 2. So there are some questions that we have here that will help us to understand what we are talking about. So let's start with the first question, which says, the first question is A, 240 meters is measured to the nearest 10 meters. So 240 meters to the nearest 10 meters. So according to the formula, our n here is equal to 10. And so therefore, the absolute error or the error in this question will be given by 10 over 2, which is equal to 5 meters. Remember that the absolute error has the same units as the measurement that you are given. So our absolute error here is 5 meters. And then in the next part of the question, where we are finding the absolute error, we are given to find the absolute error in the measurement 240 centimeters. So when you are given a whole number like this one, to find the absolute error, and then you are not given like in the first question here, where we are given to say it's measured to the nearest 10 meters. Here you are not given anything like that. Just know that this one is measured to the nearest 1 centimeter. To the nearest 1 centimeter, which we call this smallest number here as the least measure. And so therefore, the absolute error in a whole number like this one will be equal to 1 over 2, where our n is 1. And so therefore, this is going to be 0.5 centimeters. So the absolute error in this number here, 240 centimeters, is 0.5 centimeters. And then we go to the next question. The next question is 5 kgs. So we are asked to find the absolute error in the number 5 kgs. So since this is a whole number, all the whole numbers are measured to the nearest 1 centimeter or 1 kg. In this case, since it's kgs, this one is to the nearest 1 kg. And so therefore, the absolute error in this number will be 1 over 2, which will give us 0.5 kgs. Okay, so since it's a whole number, it's 5 kgs, it means it's measured to the nearest least number, which is 1 kg. Okay, so all the whole numbers are measured to the nearest 1 kg or 1 centimeter, depending on the units used. And so all you do is you just divide by 2, and then you can write it as a fraction as 0.5, in this case, kgs. And then the next one is D. So it depends on the number of decimal places. So here we have 5.0 kgs. We have 5.0 kgs. So this one is measured to the nearest 0.1 kg. So if you have 1 decimal place, so it means the least measure will be 0.1. So it's always 0.1. It's always 0.1 because 1 is the smallest number normally that we use for measurements. So here you have 0.1 as the least measure. Therefore, the absolute error will be given as 0.1 over 2. You always divide by 2 according to our formula. And then 2 into 0 here will give you 0. 2 into 1, you have 0 there. You add a 0 there. 2 into 10, you have 5. So 0.05. And since it's in kgs, you are going to have 0.05 kgs. Okay? Or the shortcut that you can use to find the absolute error in a number like this one is when you have 5.0, all you do is under this number here, you can put a 0. Under the decimal point, put a point. Under the number here, put a 0. And at the end where you have no number here, you can put a 5. And you have 0.05 kgs as the absolute error for this number here. So let's go to the last part of the question that we have. So the last part of the question that we have, which is E, we are finding the absolute error. So according to our formula, we divide the least measure, which is n, over 2. So the least measure, which is n over 2. So here, the number that we have is 5.00 kgs. So the least measure for this number here is 0.01. 0.01. So 0.01. And so for us to find the absolute error, we are going to divide 0.01 over 2. Okay, so notice here that the least measure, this number that we have here, the least measure has the same number of decimal places as the original or the true value given, except for the least measure, that the least measure ends with a 1 here. And so when we divide here, we are going to have 0.005 kgs as our absolute error. Or you can use the shortcut that I showed you in the previous question, in part D of the question, where you just say 5.00 here kgs, and then under the 5 here you put a 0, under the decimal point here you put a point, under this number here you put a 0, under this number you put a 0, and at the end where there's no number you put a 5. And so you have the absolute measure as 0, or absolute error as 0.005. And since the units here are kgs, we are going to have kgs here. And this marks the end of our lesson. Thank you very much. In this video, I want us to look at a question on approximations. And the question says, the mass M of an apple lies in the range 2.5, 2.35. M represents the mass, and 2.45. So one thing before we even answer these questions on absolute error and relative error, we have to understand is that in this question, the lower bound, we are given the lower bound, which is 2.35, and the upper bound is 2.45. And so the first question says find the absolute error. So for us to find the absolute error, all we do is we just get the upper bound. The upper bound is 2.45. Okay, so from the upper bound here, we can get the absolute error. All we do is under the first two numbers here, this one here you put a 0, here you put a point, there's a point there, and then here you're going to have a 0, and then here you bring down the 5 here. Okay, so this is the absolute error that we have. So it's 0.0 and the 5 at the end there. The 5 at the end is from our absolute error. So therefore, the absolute error here is 0.05 in our question here. And then the second question says, find the relative error. So finding the relative error, the way we find the relative error is first we have to find the true value. And so the true value will be found by subtracting the upper bound minus the absolute error. And so the true value here is going to be 5 here, you subtract 5 minus 5, you get 0, 4 minus 0 here, you get 4. And then here you have a point, and then you have 2 here. So therefore, the true value will just be 2.4. Okay, 2.4. And therefore now the question says find the relative error. So the relative error will be found by dividing the absolute error, which is 0.05, over the true value, which is 2.4. So here, we can simplify here by multiplying on top here by 100, because it has 2 decimal places, even down here by 100. And so we are going to have 5 over 0.05 times 100 is 5, over 2.4 times 100 is 240. Okay, so when we simplify here, 5 there, we have 1. 5 into 24, we have 4. Remainder 4. 5 into 40, we have 8. And so this is our relative error, 1 over 48, which we can find even in decimal form. We can use our calculator in decimal form. So we have, divide by that one there in decimal form, 1 over 48 will give us 0.0208. 0.0208 as the relative error. And so we can go to the last question that we have. So the last question says find the tolerance. So number 3, finding the tolerance. In this question, we are just going to subtract this 2.45 that we have, 2.45 minus the 2.35 that we have here, 2.35. And so when we subtract here, we are going to get 5 minus 5 here, we have 0. And then 4 minus 3, we have 1. Then we have a point here and a 0 here. And so this is our tolerance. And this marks the end of our lesson. Thank you. In this lesson, we are going to look at the relative and percentage errors. So the formula that we have for relative errors is given here. Relative error is equal to absolute error over the true value. So in my previous video, I talked about how to find the absolute errors. So you can check out my previous video and then you will see how to find the absolute errors. Percentage errors here, the percentage error or PE is given as relative error times 100. And so there's a question here that will help us. The question says a bag of rice weighs 10.0 kgs. So the question that we have says a bag of rice weighs 10.0 kgs. So this is the mass of our bag of rice. And the first question says find the relative error. So the first question. So what you do when you are asked to find the relative error or the percentage error, the first thing that you do is to find the absolute error. So the absolute error for this question, by using the shortcut that I showed in our video, in the previous video, when you are given one measurement, all you do is just put zeros under the numbers that you have. So under this number here, you put a 0. Under this one, you put a 0. Under the decimal point, you put a point. Under this number, you put a 0. And then at the end where there's no number, you put a 5. So here we have 0.05 kgs as our absolute error. Okay, the 2 zeros here, you can just write 1 0. And you have this absolute error here. And therefore, according to the formula for relative error here, you have relative error is equal to absolute error over the true value. And so here, the absolute error is 0.05, and the true value that we have is 10.0. And so when we simplify this, okay, when we simplify this, we can see on top here, we can see that the number that we have has 2 decimal places, so we can multiply by 100 on top and 100 down, so that the decimal point can move 2 steps. And then we are going to have 5 over 1, 2, we are going to have 1000 here. And so this is going to give us 5 there, 1, 5 into 10 here, you have 200. And so our relative error is 1 over 200. You can also write it as a decimal number. As a decimal number, this is going to be 0.005. This is going to be 0.005. So this is our relative error. And then the next question says find the percentage error. So therefore, the percentage error is given by relative error times 100. So our relative error here, if I use the one that has a percentage here, as a decimal point here, you can even use this one. We are going to have 0.005 times 100. And this gives us, when you multiply by 100, the decimal point to move 2 steps to the right, up to there. So you are going to have 0.5%. And this is our percentage error. Thank you very much for paying attention. In this video, we are going to look at absolute errors and relative errors and percentage errors on double measurements. So the formula given here, when you have 2 measurements that are given, the true value and the recorded value, the formula for absolute error is the true value minus the recorded value in this absolute symbols or modulus symbols that we have here. So the absolute error should always be positive, in other words. So the question says Jane measured the length of a rod as 1.2. So I'll write here Jane measured it to be 1.2 meters. And then Joe measured the length as 0.7. So Joe measured it as 0.7 meters. The true length, true, was 0.9 or is 0.9. And so the first question says calculate the absolute error. The first question says calculate the absolute error in Joe's measurement. So absolute error is given by the modulus of the true value minus the recorded value. And so we are going to have the true value. The true value given is 0.9 minus the recorded value. Since the question is talking about Joe, we are going to look at what Joe found. Joe found 0.7. 0.7. And then when we subtract these two, we are going to get 0.2 meters, which will give us 0.2 meters. So the answer should always be positive. If you find a negative answer after subtracting, when you remove the modulus symbols here, you have to change the answer to a positive answer. So the absolute error in Joe's measurement is 0.2. And then now we can go to the second part of the question, part B of the question, which says find the percentage error in Jane's measurement. So you are going to consider the measurement that Jane had, which is 1.2. So the first step when you are finding percentage error is to find the absolute error. So absolute error in Jane's measurement will be the true value, which is 0.9 minus Jane's measurement, which is 1.2. 1.2. And so here you are going to have 0.9 minus 1.2. It will give us negative 0.3, which is going to give us 0.3 meters as the absolute error. And therefore, the percentage error is going to be equal to the absolute error, or maybe the relative error, which is given by, relative error is given by absolute error, which is 0.3 over the true value, which is 0.9 times 100 times 100. And so when we multiply these two, or when we simplify here, we are going to have 3 over 9 times 100, which will give us 300 over 9. And so when we divide these two, we are going to have, by using our calculator, we are going to have 300 divided by 9, which will give us 33.3%. So 33.3%. So this is the percentage error in Jane's measure. So this marks the end of our lesson. Thank you very much for being with me. In this video, I want us to look at lower and upper bounds. So the formula given for lower bounds is the true value minus the absolute error. And then the upper bound is given by the true value plus the absolute error. So in my previous videos, I talked about how to find the absolute error. So you can see those videos and you understand how to find the absolute error. So the question that we have is the mass of an apple is 5.0 grams. Calculate the lower bound. Okay, so here's our first question here. The mass is 5.0 grams. So for us to find the lower bound, the first thing that we need is the absolute error. So we have 5.0. So the absolute error is found by the shortcut that I showed in the previous lessons. Here under this 5 you put a 0, under the point here you put a decimal point, under this 0 you put a 0, and at the end here where there's no number you put a 5. And so this is our absolute error. So absolute error is equal to 0.05. And so therefore the lower bound is found by adding our true value, which is 5.0, plus by subtracting the true value minus the absolute error. So the lower bound is found by subtracting the true value minus the absolute error. And so when you subtract these two, you are going to get 4.95. And so this is our lower bound. And so the next question says, find the maximum mass of the apple. So since we are talking about the maximum mass, we are actually talking about the upper bound. So the upper bound is found by adding the true value, which is 5.0 plus, so 5.0 plus the absolute error that we have found here, which is 0.05. And so remember the units are the same units that we have. So we have grams here, grams. So we are going to have 5.0 plus 0.05, which gives us in this lesson we are going to look at lower bounds and upper bounds. And so the formula that is given for lower bounds is the true value minus the absolute error. And then the formula given for the upper bound is the true value plus the absolute error. So in our question here, the mass of an apple is given as 5.0 grams. Calculate the lower bound. So in our question, the mass given is 5.0 grams. And so the first thing that we do is to find the absolute error. Now the absolute error is found like this. So you have 5.0 here. Under this 5 you put a 0. Under the decimal point you put a point. Under this 0 you put a 0. And at the end here where there's no number you put a 5. And the units are the same, it's grams. So the absolute error for this mass that we are given is 0.05 grams. And therefore the lower bound is found by subtracting the true value, which is 5.0 minus 0.05. And so when you subtract here, you're going to get 4.95 grams. So the same units that we have. And then for the upper bound, we add 5.0, which is the true value, plus the absolute error, which is 0.05. And so when we add these two, we are going to get 5.05 grams. And this is the upper bound, and this is how you find the lower bound and the upper bound. Remember, when the question says find the maximum simply says you find the upper bound, and when we say the minimum, that is the lower bound. So this marks the end of our lesson. Thank you. Video, we are going to look at tolerance. So the formula for tolerance is the upper bound minus the lower bound. And so in our previous video, I showed how to find the upper bound and the lower bound. So you can visit those videos and you understand more on how to go about finding the upper and the lower bound. So in the first question that we have here, the question says the mass of an iron bar is given as, so the first question, the mass of an iron bar is given as 5.0 plus or minus 0.05 kgs. Okay, so starting from here, what we have here is the true value. 5.0 is the true value and the absolute error. So the absolute error for this true value is 0.05. They are both given in the question. So when we ask you to say find the absolute error, all you do is you just look at this question and get this absolute error here, 0.05. Okay, so the first question now here says find the relative error. So in our question here, our absolute error, because that's the first thing that you need to find, is 0.05 kgs. It's given in the question here. And our true value is 5.0. And therefore, the relative error is found by dividing these two. So the absolute error 0.05 over 5, which is the true value. Now this one is a simple one. We can even divide just here. 5 into 0 is 0. 5 into 0 here is 0. And then 5 into 5 is 1. And so this is our relative error. And then the next question says find the tolerance. So the tolerance, for us to find the tolerance, the first thing that we need is to find the upper bound. So the upper bound will be found by adding 5.0 plus 0.05, which will give us 5.05 when we add these two. And so this is the upper bound. This is in kgs, and then because the units here are kgs, and then the lower bound is 5.0 minus 0.05. So when you subtract these two, you are going to get 4.95 kgs, and therefore the tolerance is found by subtracting these two. So when we subtract these two, we are going to have 5.05 minus 4.95. So when we subtract here, 5 minus 5 will get 0, and then we get a 1 from this 5, we have a 4. We put it here, 10 minus 9, we are going to have a 1 here. 0.4 minus 4 is 0. So our tolerance is 0.1 kgs. So our tolerance is 0.1 in this question. So let's go to question 2 now. So question 2 says the length. So this is part 2 of the question. Part 2, the length L of a rule is 8.2 centimeters. So the length that we are given, length in brackets we have L, is 8.2 centimeters. Find number 1, the relative error. So the first part of the question, part 1, is asking us to find the relative error. So the first thing that you do is to find the absolute error. So the absolute error in our question is found like this. Since our length is 8.2, under this 8 you put a 0, under this point you put a point, under this 2 you put a 0, and then at the end where there are no numbers there you put a 5. So the absolute error is 0.05 centimeters, and therefore the relative error will be given by absolute error, which is 0.05, over the true value, which is 8.2. And so we can simplify this by multiplying 100 on top, okay, because this number on top has more decimal places than the one that is down. It has 2 decimal places, so you multiply by 100. Even down here you multiply by the same thing. And so when you simplify this, you are going to have 0.05 times 100 is 5 over 820. 8.2 times 100 is 820, which we can simplify to 5 there, you have 1. 5 into 8 is 1, remainder 3. 5 into 32 is 6, remainder 2. 5 into 20, you have 4. And so this is our relative error. And so the next question now says, find the tolerance. Number 2. Since our absolute error is 0.05 and our true value is 8.2, so the first thing is to find the upper bound, where you add 8.2 plus 0.05, and this will give us 8.25 centimeters. And then you can find the lower bound, which is 8.2 minus 0.05. And then when you subtract these two, you are going to get 8.15 centimeters. When you subtract these two, so this is what you get. And therefore, the tolerance is found by subtracting the upper bound minus the lower bound. So we are going to have 8.25 minus 8.15. And so when we subtract these two, we are going to have 5 minus 5 is 0. 2 minus 1 here, you get 1 point here. 8 minus 8, you get 0. And so the tolerance in this question is 0.1 centimeters. And then we can go to the last part of the question. So the last part of the question here, which says complete the statement, it's related to the ones that we are from solving here. So I'll put it here, and then I'll show you how to complete this statement. So here is part B of the question. So the part B of the question says complete this statement. Here we have L. So In short, the question is asking us to find the lower bound and the upper bound. So in this question, we found the upper bound. Here is the upper bound. Here is the upper bound. We found the upper bound as 8.25 centimeters. And the lower bound is 8.15 centimeters. And therefore, to complete our statement, we are going to have, our statement is going to be, so we are going to complete our statement here. Our lower bound will come here, which is 8.15, and then our upper bound will come here, which is 8.25. And this marks the end of our lesson. Thank you.